Hello, everyone. This is Mrs. G. Before we cover any new material, I just kind of wanted to go over a synopsis of what was in Module 4. The first one was finding the common difference of an arithmetic sequence, and we used the formula D equals A2 minus A1. And this is an example that we did in class. When you have a sequence of numbers and you're trying to find what is a value that gets you to the next number that's the same. You can take that second value, that's what A2 is equal to, which is a -7, and you're going to minus that from the first one, which is a -9. So this becomes a -7 plus a 9, right? And that would give you an answer of 2. So if I added 2 to each of these, I'm going to get the next number. So if I add 2 to a -5, it's going to be a -3 in the set of sequence. All right, let's take a look when you're doing a geometric sequence, though. A geometric sequence is looking at the ratio A2 over A1. And I said when you're reading the problems, make sure you understand which sequence that they're looking at exactly. This was a problem we did when we did the geometric sequence, where you look at a sequence of numbers and it's asking you to find the difference. What has to happen between these two numbers to get to the next number? This will always involve multiplying and dividing when you're in the geometric side. And then when you're in the arithmetic side, it's going to always involve adding or subtracting to get to the next number. So in the geometric sequence, we know that we are either multiplying or dividing to get to the next number, and to find what that might be, you're going to take the second value that's in that sequence, which is a -84, divided over the first number in the sequence, which is a -14. So -84 divided by -14 will be 6. When you are given equations, you should always be writing them down before you do the problem. One, it helps you remember which values that you're using, and it allows you to focus. It tells you where they belong in the equation when you label it as such. And when someone is coming in to read what you've done, they should be able to follow what you're doing because they're following the equation that you used. So the big thing about this is using the appropriate equation based on whether it's a geometric or arithmetic sequence. Now, moving on in this section, we also covered something saying that stated this: finding the basic pattern in a table. It says, look at the missing y value to determine what it would be in the sequence. So when we have this on the homework or on a quiz, we're only looking for this piece of missing information. It has nothing to do with the x values here. So this is arithmetic, all right? We're not going to have a geometric sequence in this, I don't believe. And so this becomes D equals A2 minus A1, which is the formula that we're using. So take the value that's in the second place. This would be your A2 value, and that is your A1 value. Write that equation down, list what those variables are, put them where they belong in that equation, 16 minus 11. And what that is saying is that there is a 5 in these differences between each of these. And you can see that it's a +5. So when I add a +5 to this, the next value for that is going to be a 31. So those are the couple questions that can come from find the common difference. Let's go to the second page. The other types of problems in Module 4 is find the nth term. And again, this is divided into a geometric sequence or an arithmetic sequence. So that should be something that they note on the question itself. We have different formulas to follow in each of those categories, so make sure that you have those formulas that you can use. And this was done in class, where it says find the 87th term of the arithmetic sequence. Once I know which sequence they're referring to, I know I can come up to this box and use that formula right here. And so the A1 is going to be the first term, and N represent what term they want you to find. Is it the 92nd? Is it the 12th term? And so that's that value right here. So really it's just going to be a number. So this would be 87 because that's the term they want us to find. And then the D is something that we've already looked at on the previous page, right? When we looked at the arithmetic sequence at D equals A2 minus A1. So you're kind of combining two formulas in here. So I've written down that formula. I've taken the second term that's in the sequence and I minused it from the first term. So I'm following this formula and I get a value of 13. All right, so now that I have all of my variables listed and I have my equation, I'm going to plug where that information belongs. So the A1 term, the first term is a 1 plus, and then it says n minus 1. My n is 87 minus 1. My d I calculated was 13. So now this becomes math. You do the PEMDAS where this parentheses happens first. I'm going to multiply it by 13, and then you get these values down here. In the geometric sequence, it is an exponent. It is raised to an exponent. We practice those in class. It still has similar terms, except in the geometric sequence, we don't have a D, we have an R in our formula. And that R is referring to that ratio that we covered on the previous page. So this one says find the 10th term of the geometric sequence, and they gave us another one, and I'm using that formula because it says geometric sequence, and it's asking for the 10th term, right? Because that's what this page is about. So I've labeled what my values are, and I had to calculate my R. So I take the second one, that's A2, divided by my A1, which is my first term. So negative 24 divided by 8 is a negative 3. So I now know that that is going to be my R in this equation. My N is going to be the 10th term, so it's going to be 10 minus 1 for this exponent. So it's 8, that's my A1, times a negative 3 times 10 minus 1. So I've simplified it a little bit, and I need to do this exponent first because according to PEMDAS, that's what you do first. I get a value of this. So make sure you can do an exponent in your calculator, which we practiced. Sometimes when you feel like, I don't know if I really knew how to do an exponent, if you know 3 squared is, say, 9, right? Because it's 3 times 3, it's really what it's saying. Then put this into your calculator to see if you get a value of 9. If you put 3 to the exponent of 2 and you're not getting it, well, then that means you're not putting it in right. And maybe you do have a square button. Maybe if you had 3 to the third is going to be equal to 27 because that's 3 times 3 times 3. So if you know 3 cubed is equal to that, put this into your calculator, see if you get that. If you do, then you're going to put that in the same way. Don't forget there's a negative value here. We know what we do. We like to bold those negatives, and your answer will be a negative 157,464. All right, we also talked about functions and finding that information and whether or not it was a function. And we looked at different types of questions that could be asked to just for us to say yes or no, it is a function. We know that functions have a special type of relationship between the x and the y, but it also could be different letters. It could be an m and an n or a p and a q. It doesn't matter. But there's a special relation to those two variables, and every x has one y value. So we looked at these XY charts to determine if these were functions. So every x needs to have a y, one y value. So I can't have an x having multiple y values. So every x has one y value. So yes, this is a function. When we looked at this in class, we noticed that there was a couple x's equal 1. And when we do that, that means that when x equals 1, y can be 5 or 8. So that x does not have one y value, it has a multiple y values. It also falls apart at x equals 2 because it has multiple y values for that also. So no, this is not a function. And that's looking just at the xy tables. In this one that we did in class, every x has a y. So every x has one y value on this one. So yes, this is a function. We are concerned if we have multiple x's that are the same, because then that means you'll have y's them being equal to multiple y's. So same ones of x's gives us multiple answers of y's, but each of these have a unique x value, and so they each have their own y value. So we looked at XY tables. We also looked at looking at points if they give it to you as a question and it says determine if a set of points represents a function. And again, just like in here, you're looking to see if each x is different. And I notice that I have two x's that are equal to 0. So when the x equals 0, then it means that y could be 3 or 5. So not every x has one y value. So because of that, this is not a function. If we take a look at this one also, I have a -9 in here twice. So when x equals a -9, y can equal 6 or a 5. So that makes it not a function. So two different ways of just asking the same question, and they look differently possibly. Um, so make sure you understand they're both just looking to make sure that every x has one y. You can also do a vertical line test on a graph to see whether or not it's a function. And here is your graph right here. This is the vertical line test. Pretend that I'm looking at that line and it's going up and down, and it has to make sure that every x has one y value, and this does. So this is yes to the function. And this one here is your graph going like this and your vertical line test, right? Going up and down. And in here, it crosses here and here. So it crosses 2 points at the same time. So no, this is not a function. Remember over here, it's only ever going to cross 1 point at a time. This is crossing 2 points at a time. So this fails the vertical line test. Let's take a look at looking at the definition of a function again. I've stapled these together so they won't come out of order. So sorry about all the paper moving. All right, so we're looking at functions, and we talked about an input of values going into something called a function, and it's spitting out an output set. Now, what happens in here? In this function, there has to have a rule that they're following in order when that input of data comes in there, something happens to it to make new output information. So we call that an input output table here where you have your X values and then you calculate your Y values based on the rules. So it's going into a rule machine. Think of that. Okay. So let's take a look at one of these rule machines up here. And I'm looking at this right here. I have a bunch of X's and I'm looking at my output. My rule is y is equal to 2x for this particular example. So every time that there's an x in this rule, I'm going to put where it lives so I could calculate the output, the y value. So in this one, the y equals 2x, I have y is equal to 2, and my x is a 2, so that would be a value of 4. And this one, y is equal to 2 times x, my x is 3, so it's going to be 6. And in this one, it's 2 times x, which is a 4, so the value will be 8. So that's a typical chart that you might find when you're doing functions, but for you to just understand what it means to be a function, you got to follow a rule in order to produce the output data. Let's look at one more of that. All right, so this is y equals x plus 1. That is your rule that you're following. You're putting all those x's where they are in there to calculate the y's. And we're just going to do these ones up here because I've done the other ones there. So where the x lives in this rule, I put that in there. So that's a -3 plus 1. So that's going to be a value of a -2. So it went in, went through the rule machine, and out came a -2. And this one, the x is a -2, and I'm adding a 1 to it, becomes a -1. And I'm just going to keep going where the x is. I'm putting that value in it so I could calculate it. Oh, I got a big old 0. And then this x is a 0 plus a 1, and that gives me a value of 1. So let's kind of summarize what exactly functions are telling us other than this little rule machine. Well, we just did a y equals 2x, and we also did a y equals x plus 1, if I'm not, you know, correct here. And how you can write that in another way is say f of x equals 2x. What it's saying when I'm looking at the x is that is the input, what you're putting into the machine, is equaling the output. All right, so when I do that, it's saying the f of x is equal to the y, right? Because that's my output. The machine had an input, right, that made some output, and there was a function that it went through. My x's are here, and I view these are the letters that we're doing. So their function is what I put in there, and that equal to y, which is my output. But why would we write it f of x equals 2x? Why don't we write it just f of x equals y? Why are we writing? Because it looks like we're using x's twice. I want you to think about this. If y is equal to 2x in this example, all they did was replace that with what y is equal to. So they've replaced it to f of x equals 2x. And doesn't 2x equal y? So they call it the function of x is equal to 2x. But I want you to think about this being the input, that being the output. And it's really describing the rule of the function, which is going to give us our y's. They give us a y. So if I take a look at this one, again, it is the input is equal to the output. We know that the input is always an x, the output is a y. And we know that the y here was equal to x plus 1. So I'm going to, where the y lives here, I'm going to put what he is equal to. So it becomes f of x equals x plus 1, right? That's the rule that we are following to find the output. So I hope when you see any type of functions, the f of x equals x plus 1, that it makes sense that we are describing the output. We're describing how to calculate the y, what the rule is in doing so. All right. Let's get to the new stuff, and that has to do with domain and range. I've pasted some graphs on here, and there's some transcribings that you need to understand on how to write your information. All right, so let's take a look at this. It says domains mean all possible x values. That's what the domain means. Graphing is graphing x and y values, right? That's what we're going to be doing. And so we're going to be finding domains, which is going to be all possible x values, and we're going to be finding range also, which is going to be the y values. So when we're graphing, we can have a closed circle or an open circle. So hopefully this came out well, that you can see that this is a closed circle and that's an open circle. When we're doing this process, when you have a closed circle, what it's saying is it is included, something that is included in the graph. And when there's an open circle, it's not included. What the heck does that mean, right? So let's just say, well, I just want to make sure we understand what a closed dot means, that you include that value, and open dot means it's not, okay? So let's take a look, what that is that saying? What that's saying is, let's say that I'm finding a domain, and it often looks like an ordered pair. All right, so when something is, say these are these values, when something is not included, let's say the value was 2. All right, I don't know what this is, but say the value is 2, it means all the way up to like 1.9999999, but you can't include the value 2. So if that isn't part of our answer, I'm not saying this is the graph to be looking at that, I'm just making these values up. If we come up with that our domain has a value of 2 and it's not included, it's as close as possible as you can get without including it. Okay, so it takes a little bit to look at these for a little bit, but let's look at how to state this when we're writing our ordered pairs. So right here, you can see that my ordered pairs, I made this up, as a -2 and a 2. When you have a square bracket like this, it's talking about that that value is included. So a square bracket like this means included, and something that has a parenthesis in either way means not included. So I don't want you to think it's always in this direction. It could be in this direction, not included, etc. So when I do that, I'm saying this has an open dot and this has a closed dot when it has that square bracket. So let's take a look at these examples. So when I have the square bracket of -3 comma 5 with an open thing, it's saying that this value is included and this is not. If I'm going to write it out, we're going to look at graphs, and we're going to use both of these definitions. I want to wrap our minds around it before we're actually looking at graphs. When we're looking at domains, we could say, hey, it goes from a -3, and then we say less than or equal to because it's included. Equal means it can equal a -3. Here's X, your domain, and it's less than 5. I can't put the equal sign here because it's an open thing, means it's not included, right? It's 4.99999, but that does not include 5. Let's take a look at this. I have an open 1 comma 4 with a closed bracket. So if I'm going to write it in this format, I would write 1. This cannot be included because it's an open parenthesis. Write your X, and because this is a closed one, I can write less than or equal to, I can't write the letter 4. The letter, the number 4. All right, now these both have closed brackets and these both have open ones. So you could stop the video right now and see if we agree on the writing of this domain practice to over here. All right, because it has a square brackets, I can use the less than or equal to sign because it can include that value of 2. And the 5 has also got a square bracket, so I'm including it. This one with the open values are not included, right? It goes all the way up to, but it doesn't. And it looks like that. Now, if we were graphing this, okay, this would be an open circle and a dot, right? Because that's what the dots mean, that you do include them. 2 closed ones with those closed brackets, those are going to be 2 solid dots. With these open ones, they would have open circles, means you do not include that actual value. And that's also what this is saying. We're not including 9, it's up to 9. Okay, so let's take a look at what we'd really be doing with this type of information: the closed dot, the open dots, these brackets, all of this. So let's put it all together when we're looking at a graph. I pasted these from the Delta Math. So what we need to do when we're looking at a domain, so make sure they're mixed up between domain and ranges in there. We are looking at the X, right? And this is your X axis, your Y is over here. And to be able to do this, you need to read it from left to right. So go to the farthest left, move over to the right. So I'm going to take a look at this X value, and I wrote these ordered pairs down. I like put my eyes as close as possible as I could to read it for me to be able to see that. And then over here, I got the points are 11 and 5. So this is an X and a Y value, right? This is my X, comes over 11 spaces, and I go up 5, and that's how I got 11 and 5 there. And this particular one, I'm going to over here, a -11, and I come down to the Y is also, ooh, should be a -11. See, there I go, made an error. -11, -11. So let's look at our X values. We're going to read from left to right, right? Left to right. So here's a -11. That's my X. And here's my other X. I'm reading it from left to right. Now I'm trying to figure out who gets this kind of brackets, who get those kinds of brackets, right? I notice that this is a dark circle. So I'm going to put a closed bracket because that means it's included. This is an open circle, so I'm going to put that on that because it's not included. Now I want to write the other way that I could write it, which is where the x is in the middle and those values are a negative 11 and 11. So what kind of signs go in between there? Because this means that it includes it, I'm going to write this less than or equal to because it includes it. This is an open one, so I'm just going to write less than. And that's how else I could express that. All right, let's go to this one. And again, I took the time with my poor eyesight to write these values down. So when you're doing this on the Delta Math, you might need to blow it up a little bit to read it. But again, I'm going to go from left to right. So I'm going to pull out those x, y values over here. I'm only looking at the domain, so it's going to be the x, and I see a negative 11 and an 8. Now I got to think again about these signs and how they come into play here. Well, these are both heavy dots, so that means that they are included. So it has that type of notation. And then I'm going to write it where it looks like this value. So I know negative 11 is over here, 8 goes over here, and x is in the middle. And I'm trying to think about my signs. They're always going to be less than. So this is less than or equal to because that's a closed bracket. And this is also less than or equal to because it's a closed bracket. Okay, and that's based on the fact that there are solid dots in this graph. Let's take a look at two more, and then we're going to do ranges. So to save time, I've done these reading of the ordered pairs. Make sure you can do that. Make sure that you understand that that's a negative 5 for the x and a positive 5 for the y. So make sure you can do that. And this one, right, we do our x first, which is a 5, and then we do our y, which is a negative 11. Reading from left to right, I have a negative 5 and I have a 5. So now we got to put those brackets around it, and this is an open circle and that's an open circle. So it looks like this. And then when I do my x's, right, I put my little x in there. I can write it in the same way. These are all going to be less than. I can't do less than or equal to because the dots are open circles. They're not solids. All right, why don't you stop the video here, see if you can do the math. Let me just to help you, I will write the notations here, but again, make sure, I hope it's clear enough that you could do this and read it on your own, but take a look at it. Pause it for a moment and then see if we agree. All right, reading it from left to right, I get a negative 11 and 11. And these are both open circles, so they get those kinds of notations. And when I'm doing this, these are all going to be just less thans because I can't put less than or equals to because they don't have the square brackets. All right, let's read this here on the other side where it says determine the range graphically. And this you're going to read from the top to the bottom. We are looking at y's. These can be a little bit trickier because I'm better reading the horizontal and not the up and down part that these require. So let's take a look at these, but just realize they're just a little bit trickier. So this is our y. So now we're interested in the y, and we want the highest point and the lowest point, right? We want to go from the bottom to the top. So the x's last time, or the ones that I picked, always seem to be where you started and ended. But this, we're looking at who goes down the lowest, who goes up the highest. So in this one, it is a negative 3 and an 8. Negative 8, sorry. Negative 3 and a negative 8. Hope you can read that. I'm going to redo that. Negative 3, negative 8. And this is the tallest one right here. That's our tallest, not the end here. So this is 8 and a 7, right? Because we're going up. Who has the tallest one? So what I see from here is a negative 8 and a 7. And we have to determine those brackets, okay? So if you take a look down here, hopefully you can see it. It is a dark circle. So that is a closed bracket. And this dot that they've put here is also enclosed. So that is a square bracket. So writing this for the y's, it's going to look like this, right? -8 less than or equal to y less than or equal to 7 because it has those square brackets because they had the dark circles. We're not looking at these. We didn't use them. We used those circles. Let's take a look at these over here. We're doing the range. And if it helps you to write your why, helps you to put an arrow to remind yourself to read it in that way, then do what you need to do. So this over here is a 5 value from the x. And it's, again, it can be a little bit hard to see. It's a -1 on the y. And this one over here is a 6 and a 7. So I'm going to pull out the y's because this is the lowest part of the y and the highest part is here. So -1 and a 7. Open circle. So we put our parentheses are like that. And when I write the notation in this way, it looks like that. There are no less than or equal to's because there's no dark circles. All right, let's take a look at this one. All right, and this one, we're looking at the lowest point of the y, right? I'm going to draw myself. I think this helps me. Um, so this is a -4 and a -1. Now I'm looking to go up as high as I can. The highest point y gets is up here. We're not looking to read from left to right. We're looking to read from bottom going up. So this one over here is a -11 and a 6. So reading from the bottom going up, I'm going from a -1 to a 6, right? Because I'm looking at the y. And so this one down here is a closed circle if you can't see it. So it's going to get a square bracket. And this one up here is an open circle. Again, hopefully you're being able to write this quickly now. It looks like this because the square brackets get the less than or equal to, and the open brackets get that. So these are the range ones. The other ones on the other page were the domains. And again, you just need to be careful when you're reading it. If doing things like this help you keep your mind, remember to go for the lowest to the highest point on the Y, then add those extra tips in to be able to keep your mind straight, as well as being able to maybe on the domain one, make sure you're always going from left to right. These are the type of graphs that would be on the test. I know that Delta Math has some, I don't know why I was drawing an angle there, has some weird ones that look like this. Those graphs would not be on this exam at all. It's just going to be graphs that look similar to this. All right, everyone, finish up your Delta Math, and I will see you soon in class to take the exam.